The IRMACS Centre is proud to present the SFU Fellows of the Royal Society of Canada Seminar Series. This bi-weekly series hosts 5 presentations per semester. For the Spring 2012 semester, the presenters belong to the Departments of Earth Sciences, English, Biological Sciences, Economics, and the School of Resource and Environmental Management. Today's speaker is Dr. Mark Jacquard from the School of Resource and Environmental Management.
Thank you to the Royal Society for inviting me to speak today, and to all of you for coming out to hear my talk. I have about 30 slides. I hope to speak for 40 minutes because I really do enjoy discussion, and so have all those questions ready and we can discuss this way, but also this way, any way we want to do that. The original title I had for this talk was Climate Delusions, the Good, the Bad, and the Ugly. That's always the problem when someone asks you, what's the title for your talk, about a month or two ahead of time. So then you're, oh, I know, this is a really interesting thing I'll do. I'll categorize different kinds of climate delusion. Anyway, it's not there now, so didn't do that. I just want to give a quick overview of my talk. Climate scientists have concurred for decades that humans are changing the climate. Since 1988, world leaders have promised action, and economists have estimated fairly modest costs of reduction if these are spread over several decades. But nonetheless, we've had negligible success. In spite, if you think about it, good progress that we've made on other environmental challenges. So why isn't it happening here? Climate actions of some politicians are not consistent with their promises. Why is that? What should we do about that as researchers or as people that are in the policy modeling realm, as I am? So this leads to increasing attention on challenges of human decision making, both at international, national, and even individual levels, and with lessons for science communication, which I want to try to promote here. Questions of policy design, and even issues of citizen political engagement. And for a sustainable energy policy modeler such as myself, this kind of stretch issues that I'm thinking about, it takes me out of my, I'll call it my professional comfort zone. But at the same time, I feel that the situation is critical. And so I'm also going to be inviting all of you to reflect upon what any of our roles might be in this kind of situation, if you believe that there is a very major threat to the planet that humans are in some ways so far incapable of acting on. So my talk starts out a little bit on the climate science. I'm not a climate scientist. I do study risk analysis, so I look at more of the climate challenge as one of 9 doctors telling me I better do something about what possibly is a cancerous tumor, and do I go and just find that one doctor who says don't worry about it, or should I maybe pay attention to those 9 scientists? So that's the kind of risk analysis approach that I bring to this issue. Taking some of the information that scientists seem to have a pretty close consensus on, I want to show this particular diagram. Now, I don't want to spend a lot of time in the diagram. I don't have time for that in this talk. And so apologies that I won't be working through it in detail. I simply want to point out on there that our temperature today, according to the scientists, is about 1.2 degrees Celsius higher than pre-industrial times. That's my 0 on the left there. And then I want to focus on the bottom row, which is thinking about the nonlinearities, the discontinuities, threshold effects, tipping points. And that's the reason why scientists have drawn this line in the sand, if you want, or this line on the thermometer of 2 degrees, and said, once you're starting to get 2 degrees different from pre-industrial levels, then we think there are more nonlinearities that could kick in, positive feedbacks that have you spinning away and having less control over that system. That, in other words, just the amount of CO2 or greenhouse gases we put in the atmosphere is not just this dial we can turn up and down to adjust what the temperature is. And so an example would be methane in the permafrost, that as you melt it, starts to release. It's a potent greenhouse gas. It has temperature effects, and then we continue on. The system itself starts driving temperature change. I also want to show you a single slide which helps a little bit with, I am going to throw out a lot of numbers about atmospheric concentrations, reduction targets, and then a little bit on the temperatures, and that can be confusing. And one of the sources of confusion is that carbon dioxide is the principal greenhouse gas that humans are emitting, and it's primarily from burning fossil fuels, but it's not the only greenhouse gas. As I said, there's methane and other greenhouse gases. But what we've tended to do, or the scientists have tended to do, is convert those greenhouse gases into their CO2 equivalent in terms of their climate change potential. And so I, as a modeler, trying to look at the whole system, we're always taking information from the scientists about all of the greenhouse gases. So the models that I look at, the international modeling groups that we work with, we're always in CO2e, CO2 equivalent, but often public groups and so on might focus on CO2. And you can't blame them in a way. I mean, this again is this whole issue of science communication. We tend to focus on accuracy, but how does that help with communication? So I wanted to at least put some explanation right here with a fairly simple table. And basically on the right-hand side, it's likely temperature change, and I've got the CO2 there, but I've also got CO2e. And as a rule of thumb, I'll often say that just add 100, just to make it easy. It's not really true, because we may make more progress on methane than we do on CO2 into the future, so you have to be careful with this, but as a rough rule of thumb. And what you can see on that table is that the CO2 was about 280. I think they do have CO2e numbers, estimates as well. So temperature change 0. As today we're at 390, the CO2 equivalent I think is around 460, and we're at 1.2 degrees, as I show in parentheses there. But if enough time went by at that concentration in the atmosphere, then it would be a 2.2 degree Celsius change. So we're already above where we need to be in terms of that 2 degree threshold. So if you look at the bottom row, you see that there's 350 CO2, or about 450 CO2e is what we're identifying as that threshold. And that's why you would have seen, or there is something called 350.org. It's a rallying cry for a lot of people who are concerned about climate change. And I'll talk a bit more about that later. What path are we on right now? Well, our current path, if we just keep projecting up, is in the realm for CO2e that I work in of 750 to 850 by the end of the century. That's another complication in my talk. Sometimes I'm going to say this is where we'll end up at the end of the century, but as a modeler, we're especially looking at where do we need to be by 2050, so less than 40 years from now. So I'll often talk about 2050. Politicians have picked that as a target. We as modelers try to see what that means. And it's more realistic for us modelers because technological change could be very dramatic, and the further out you go, also there's considerable inertia in the energy economy system, and that's going to be a theme of my talk, actually. I'll get back to that one. So because of this, there are now scientists who are contemplating ultimately a 4 to 6 degrees Celsius increase, getting close to there even at the end of this century. And so my slides will be available, but right there you have a website for a conference that was organized in Oxford not long ago about scientists working on this, both the climatologists, but ecologists, people who understand Earth systems, abiotic Earth systems, and so on. I have one more sort of physical system slide to show, and John Clegg gave a Royal Society talk here that I think some of you probably attended, and it's a slide that he put up, and so I don't want to spend time on it again, and it's a pretty simple slide. It simply has sea level on the left and global mean temperature, with today being about 15 degrees and sea level counted as 0. In John's talk, he talked about all the complexity about what is the real sea level and when was it over time. So I'm glossing over that. Apologies. And the only thing I wanted to point out was that if we are indeed headed towards 3, 4, even 3 degrees higher, then the estimates are that sea level by 2100 might be half, 1 meter higher than it is today. But as John pointed out as well, when you take in all of the lag effects, if we stayed at that temperature, well, the one indication is we have is the Pliocene era 3 million years ago, and you can see that the sea level was tens of meters higher. So that's kind of thinking about lags. And the reason I bring that up is not that I have any expertise in that whatsoever, but as a sort of segue to the fact that I'll be talking about lags in the energy economy system. Because I'll be talking about those lags that I know about and trying to communicate that to the public as I do, or to other researchers, because they are the way in which we sort of say, we can say, what should we be doing today in the tar sands, with an oil pipeline, with a coal-fired power plant, in order to get to something that someone's promised to achieve by 2050. And that's the main theme of my talk. There's one other slide I want to show here, is simply a way of representing uncertainty. Again, my focus is more in decision analysis. People talk a lot about the uncertainty of the climate science, and that uncertainty is somehow an excuse for waiting. And actually, a lot of the uncertainty probably won't get resolved for a very long time, even with waiting. You almost have to wait and see what happened. And one way to depict this is with this, these two figures. This is from Ronald Prynne at MIT, the Science and Policy of Global Change Institute, something like that. And I use a lot of their material, actually. You'll be seeing that later on, because it's an interdisciplinary group. It's got economy, energy modelers like me, and it's got climate scientists as well. And Prynne is on the science side, and here he's just trying to depict the uncertainties. And the point I wanted to make is that we will continue to have uncertainty within each one of those circles. Right? That we say, well, with no policy, we know emissions are going to keep going up, and we know the temperature will go up, but we have different, depending on what the parameters are in models, we have different estimates. And likewise, if we are able to implement policy and prevent emissions from rising, but here's the changes that we think are going to happen once we start to stabilize. And I forget what particular policy or concentration this was, but the point is the difference between the two. That's what we know about. That's what scientists feel very confident about, that yes, we will have different temperatures if we don't do anything about it. And that's what I want to emphasize. So unfortunately, that critical difference from a decision-making point of view gets glossed over as people focus on, oh look, the scientists aren't sure if it'll be 3 degrees or 6 degrees that the temperature is going to increase. Now I'm moving away from the science to the area that I'm more comfortable in, which is the politics and the political promises of where emissions should be and what needs to happen in an energy economy system to get there. So what were those promises? Well, political leaders promised at Copenhagen in 2009 not to allow temperature increase to exceed 2 degrees Celsius. And you remember from my earlier table, that's 450 CO2e or 350 CO2. And you know that we're already beyond that, and so what do I have to show to try to achieve that? And there's groups of international modelers who work on that, and I'll talk about that in a minute. Because of that, then politicians did say, okay, we get it. We can't just promise 2 degrees. We have to say, what am I going to do to get there? And so most rich countries promised to reduce their emissions by 80% by 2050. Now, Stephen Harper promised 65%. I don't know, it's a little bit of a one-upman or one-downman or whatever you want to call that, but it doesn't matter. I'll stick with the 65%. Be happy if we could figure out how to get there, and had some sense that he was trying to get there. Now, so remember that so I've been talking 450 CO2e. What about 550 CO2e? Well, if you were to think about that, the Ronald Prynne Wheel of Fortune, if you want. Even 550 with only has, so what we were saying is we had to get to 450. Then we've got a very high chance that we won't exceed 2 degrees. Now, I'm going to stop talking about 450. none of our models can reach it because of the inertia in the energy economy system. In other words, greater than 2-degree change is something that we are not modeling anymore. And I got my students to look at this massive the 10 leading groups in the world who do what I do. Their study based at Stanford just a couple of years ago. Everybody's model, we just call it our model fails to solve, to try to hit the 450, aka 350 temperature. So I'm going to be talking, so that should be scaring you already, but I'm going to be talking 550, that's the world I live in, and trying to see if we can get to 550. Well, what about even to get a 50-50 chance, so not an 80% chance, but a 50% chance of getting to 550. No, sorry, said that wrong. 50-50 chance of not exceeding the 2 degrees. So getting to 550. Global emissions would have to fall 60%, okay, by 2050. So this is for a temperature change to not exceed 2 degrees. Have a 50-50 chance of that by the end of the century. Here's what has to happen in the next 40 years. And I'm going to show you a diagram that'll explain that. So since the rich countries have sort of recognized that and said, we got to get our emissions down 80% by 2050, what should be happening with poor countries? Now remember, poor countries, 1.5 billion people, no electricity, over 1 billion people not using gaseous and liquid fuels yet. So there's a lot of inertia to finally use some modern energy in that system. And emissions are tied to that, as I'll show, or have been. And so what about if we said, I know, they'll go up a bit, but then come back down again. So this is what people are trying to model. So we said like a 20% reduction from 2010 levels. They've been growing at a tremendous rate. So what does this mean? What does this mean for the global energy system? And that was my point again, just to reiterate, just as the climate system has path inertia, so does the energy system. And one way to look at that is, so here's that 550 CO2e target that I'll mostly be focused on. And this is from Nicholas Stern, just from an article I read of his that he just published just a month ago. But it's very similar to a lot of the modeling. And the gray area is sort of the uncertainties we have. We make different assumptions about rates of technological change, rates of equipment turnover, how fast do buildings change, factories, vehicles, and so on. But what you can see there is that, think of this, the integral, the area under the curve, it's those cumulative emissions that humans send up, that total quantity that tells you what's going to stay in the atmosphere. Of course, there are certain amounts there's a rate at which oceans absorb CO2 and so on. But in general, we're looking at the area underneath the curve. And what you see is that once you project past 2050, you need very little to be happening because of this huge bulk of emissions that happened before, in this case, I've got a line at 2020, but let's say before 2012, and what would happen after 2012. So we're trying to turn the ship around. What might that look like? And so you can see there's that 60% global drop that I was telling you about. And the other thing I wanted you to take, the other takeaway from this diagram of Stern's is that emissions are going to have to start falling before 2020. So global emissions, which are still on a very rapid upward path. So this is us trying to characterize for you getting to 550 or stabilizing at 550 CO2e by the end of the century. But I'm going to focus on the next 40 years. And I'm going to start by trying to give you sort of just a visual of the global energy system and what it looks like. What you see, and I've broken it out, renewables are at the top there, although biomass is also, if you're not destroying the land's productivity, it's also renewable. But in some of the figures, people will separate it out. It's because so much biomass is used in traditional ways, just burning for heat and light. What you can see is that it's 85%, it's 15% CO2 free, 85% fossil fuel based, and so CO2 emitting. And also, I mean, just look at the growth here, tremendous rate of growth. I was born in the mid-50s, and just thinking about what's gone into the atmosphere in my lifetime alone, it's quite shocking. So our system has grown. The global energy system in the last 100 years is about 14 times larger than it was 100 years ago. So what will it be 100 years from now? What will it be 50 years from now? And so what do we think about those next 50 years? And so that's what I study, is what kind of inertia or momentum, if you want, is built into that system. Now, if we're going to dramatically reduce, I want to bring it into real terms for people. Like, what does that really mean? So I'm going to talk about CO2-free versus CO2-emitting energy system. And the thing to pick up here, though, is that it doesn't mean fossil fuels versus non-fossil fuels. The ways of reducing greenhouse gases are use less energy, substitute away from fossil fuels, or possibly, when using fossil fuels, convert them into energy we can use, but capture the carbon and bury it. So we can talk about that later on, but that's certainly one technical potential. We're already doing that in some cases, so it's not something we can call as simply pie in the sky. Whether we can scale it up is another question. So here's a figure in which I talk about that we're a 15% CO2-free energy system. But to get to 550 CO2e, to stay below or at or below 550, what would that system have to look like? Now remember, that is a global energy system that is growing. That's why the pie is bigger. But in that growth, I've assumed way more energy efficiency than we've had in the last period. And so the growth isn't nearly like that 14-fold kind of growth in 100 years. But so you can see that to get that 60% reduction in a growing system, we need sort of 80% CO2-free globally. And that also tells you, then you work backwards through that system and say, what does it have to look like in 2030? Now, I'm getting older, and so when this was like 2030 way out there, and then I realized, oh, you mean 18 years from now. Wow, I know how slow things change. The hybrid car was introduced 15 years ago, and now in California, it's about 4% of new car sales. It's going up quite rapidly, but there's an example for you. So 50%, so what do we think we need to have by 2030? Something like 50%. So, CO2-free share, what does that mean? And I just want to give you a really quick description. What would electricity generation look like? Well, it would be 90% CO2-free by 2050. And that's the cheaper thing to do. And in some jurisdictions like British Columbia, it's already 95% CO2-free. But we're really talking about all those places where people burn coal or gas, and even a few places in the world where they burn oil. And what are we going to do there? Some cases it might be carbon capture and storage or switching to renewables and nuclear. What might buildings look like? I'm going to go quite quickly here. And then finally, what about the transportation sector? So we're doing a lot of modeling on vehicles right now, and just giving you that example from hybrids. How do we get that transition to happen? How can we get it to happen more quickly? But I wanted to give you just a sense of what that means, because also though, guess what? In the vehicles, we now have commercially available electric vehicles, like ones that are decent. I mean, they're not able to right away attract everybody. That's normal with new technologies, but performance indicators we have are pretty good. We've been able to, Brazil has had 50% biofuel vehicles for 10 years now of their sales. So these are not pie in the sky kind of things that we have to do. That's the point I'm trying to get across. These are technologies in our models that have already got market share that we're simulating. Now, let's link this up then with, but we know that what I call the capital stock, it's simply the things we invest in, infrastructure, buildings, factories, electricity plants, cars, even light bulbs. Light bulbs, pretty quick turnover. But what about the time it takes to build a transit system or to renew your factories? That's the kind of data that I have in our model. And of course, we can do dramatic change. I call that the Germany in World War II scenario, where, and I don't mean to make light of it, but where you do blow up your capital stock. But that's way more expensive, as you can imagine, and so very daunting. So what about our politicians? What have they been saying? Well, the Canadian government is aggressively, as people know, promoting tar sands expansion, including Keystone and Gateway pipelines. And yet at the same time, so I'm going to ask, is this consistent with the 2050 promises that Stephen Harper made? And I'm going to say, or even just a 50% reduction. And the reason is because I'm going to show you a study where people, I don't know, at some point he said 50%, and then he said, no, it's 65%. And a group of modelers at MIT said, well, we'll give them the 50%. because we want to see what would happen. And he was part of the leaders who promised, that we won't allow the temperature to go beyond 2 degrees Celsius. This has been brought up at G8 meetings as well. It's not just at that Copenhagen meeting. So what does independent research consistently say? So this is me as a scholar. I work a lot with a group at Stanford University called Energy Modeling Forum. And what they do is bring together the leading modeling groups from around the world in these big mega studies, where we're all competitive. We're trying to show our models are better than anyone else's, and yet we do these great comparisons. And I'm not going to show you any of the results from that, but one of the teams that participates quite frequently is the group at MIT in that same institute that I was already describing. So that group took a look at the Canadian tar sands, and they said, what if by 2050 we weren't trying for a 60% reduction in emissions, but we're actually looking to 40% reduction? And what if Canada's target was 50%? So just to flag, this scenario then does not keep below 550 CO2e. But in that scenario, what would happen to tar sands? And so here's the study right here. You can get it off their website, Canada's Bitumen Industry Under CO2 Constraints. And the head of the energy economy side there is John Riley, the second author on this paper. So what is the tar sands future? So I'm going to summarize it really quickly and just try to get you to just try to communicate one key concept here. So over this 40-year time frame, what would they do? Well, you'd have to have some kind of regulations or some kind of emissions price, like BC's carbon tax. And in our models, we simulate how do those regulations or economic instruments like a price, how do they simulate and at what time? When you do that, what they found, and I mean it's pretty obvious actually, is that investments today in tar sands production and pipelines are inconsistent with Harper's promise. And even when that global reduction is only 40%. And just here's a quote from it. The main reason for the demise of the oil sands industry with global CO2 policy is that demand for oil worldwide dropped substantially. Like you have to be using less, you have to be burning less gasoline dramatically to hit those targets that we're talking about. So you'll hear a lot of people sometimes talk about peak oil, but actually if humans deal with the big risk we have of climate change, peak oil goes away. You're not using oil anymore. So just to give you one figure from their report, there's too much detail on there. Just look at the top and bottom line. The top line is a projection of where oil prices would go, international oil prices in real terms under their scenario, and the bottom line is what happens to world oil prices when the demand is falling through the floor for world oil. That's kind of one simple message that I should want to get as an energy economy modeler, is to think about what happens to the price of coal when we act on climate change. It plummets. So when people are out doing calculations and saying, oh, solar power can beat coal plants, wind can beat coal plants, we don't have to have this policy, wind's getting cheaper. Just remember, as we really started to replace coal or oil, what happens to the price of coal and oil? They plummet. It changes all the economics. That's that's the work I do. It's a system analysis. I teach in an interdisciplinary program, a lot of students who are ecologists, and I say, you guys love feedback effects and interconnectivity of systems. Well, that's what's happening in the economy as well. And then the last one is, this is interesting because I did serve 3 years on Canada's National Roundtable on the Environment and the Economy, and I was appointed by Stephen Harper shortly after he became Prime Minister. But I'm kind of, everybody else there, as I started to realize, are appointed there, and I don't want to insinuate too much, but I was amazed at how many of them were former vice presidents of the local Conservative Party Constituency Association, or a former MLA from the Conservative Party in Nova Scotia or Ontario. I think it was universal in my own little survey of the 12 of us when we were chatting after meetings. But that panel also was, Harper asked them to look at his 65% target, to say, well, what would have to happen to Canadian emissions to hit that target? And that's a document that you can get. I didn't put the website, well, it's on the National Roundtable website, and it's called Achieving 2050. So this was literally a direction from Stephen Harper. Please simulate this. It's interesting, they hired a group of my ex-students to do the modeling work for this. The staff did. So this is a very complicated process with a lot of checks and balances and almost a built-in bias against wanting to contradict any policy to sell more Alberta oil. And yet what you can see is that the emissions, there's the Canadian government targets. Harper also has a 2020 target of sort of 17% reduction from 2005 levels. But the point is that emissions must start to fall right away. And if you look inside those models, it's very similar to the MIT results. What happens is the tar sands production has to fall pretty quickly, starts falling now. You don't invest anymore in things that would increase production of tar sands. So what are the conclusions? The world's not on a path to stabilize by 2100 at 450. That's clear. Even though we have people demonstrating and protesting and we have governments saying we're committed to that. We're not on a path to stabilize even at 550. And Canada is not on a path to reduce by 65% or even by 50% by 2050 and what it's doing right now. What are we on? As you saw on that one of the very first slides, the table that I had, we're still on that path to 750 to 850, somewhere around 800, which would be a 4 to 6 degree kind of increase. So now the last part of my talk is to talk about this failure to act and trying to understand it and what might that mean for research that I do or others. One thing I want to point out is we've had past successes. So fortunately, I have a colleague, James Meadowcroft, he's a Canada Research Chair at Carleton, and I almost need to talk to James every now and then, so him to remind me that we've had successes with other environmental challenges. Because you sort of say, well, it's impossible. You know, fossil fuels are ubiquitous, as I showed. Our system is totally on fossil fuels. Well, acid emissions were from all uses of fossil fuels, natural gas, coal, burning in cars, and we got acid emissions down. So it's not. It is a bigger problem, but I want to be careful not to just sort of characterize it as way out there. In fact, if you were to look historically, I would argue we came very close at several opportunities. So the failure is now approaching 3 decades. And so I am asking, are these emissions a more difficult problem? And what are the specific challenges? Well, I'm going to run through these fairly quickly. I think they're pretty obvious to people. It's a global public good, so you need sort of everybody involved, and I'll come back to this, and some enforcement mechanism. We have those delayed effects that I've been talking about, so the bad things are not here yet. They're somewhere in the distance, and are humans capable of thinking in that line? We have big issues about who pays, and this is a standard. The psychologists will tell us, but I don't think you need to be a psychologist, that humans are biased in terms of their own self-interest. And so it's very interesting. I sometimes get quite frustrated when people say, everybody's going to get together at Kyoto or Copenhagen or Durban, and we're all going to agree on where emissions have to get down to, which they always do agree, and then we're going to agree on what each of us will do to get there. And of course, they don't come close at all to agreeing. And why would that be? Well, it all depends on whether or not you're a poor, you say, well, I'm a poor country, they're a rich country. Historically, they emitted a lot. We didn't. We have fossil fuel endowment, and we've provided fossil fuels to everyone else. So don't be hard on us. There's so many different ways that people can twist this thing in terms of what is their own self-interest. And then we have the uncertainties that I already talked about, and can those be used as an excuse? And then finally, all of our analysis, and I have some slides in the extra slides if we get to that, show that it's actually not that expensive to switch to a low emission system over several decades. But you got to start, and that has costs. Those costs, some of them are economic, and some of them are almost psychological, institutional. So we're kind of locked in to burning fossil fuels, and that plays itself out in so many different ways. Also, I think in all of this, there's been a critical role of the U.S. I mean, we look to the U.S. for leadership, or at least have on the planet. The U.S. has been Close, very close. In the Clinton-Gore era, it played a global leading role on this. It was ahead of the Europeans. And then, I'll say that we've had some bad luck. George Bush. The kind of delays that went on in that period really gave time for those people who felt, oh, we're going to be losers as we reduce CO2 emissions, for those people to get more and more sophisticated and to start learning from, and in some cases connecting with and using the very same people who helped in the United States work against smoking legislation and working on acid rain and so on. And Naomi Oreskes from the University of California at San Diego has a wonderful book, Merchants of Doubt, that categorizes that in the United States. It's very focused on the United States, though, because we haven't seen the same thing, even in Canada until now, maybe, nor in Europe to the same extent. So U.S. leadership and its leading role in the world has been critical in trying to deal with this global public good. And then, of course, we've got, it's even gotten caught up in polarized politics. If you look in 1997, there's a poll, 52% of Democrats, 48% of Republicans, not bad, that think that humans are changing the climate. We should probably act. And so you had John McCain sponsoring bills before the U.S. Senate. You had Arnold Schwarzenegger, a devout Republican, coming out and saying, we got to act on climate change. That's unfortunately slipping away from us right now. There's a real, and so there's a poll that what was a 4% gap in 97, just 11 years later, was a 34% gap. And I hazard to guess that if I see the results from a similar poll today, it could be even worse. Then we have all these different biases that I'm just going to run through quickly. I like to start it out with a quote from Upton Sinclair. It's difficult to get a man to understand something when his salary depends on his not understanding it. And so then there's been various techniques. I won't go through these. Exploiting anti-science bias, exploiting anti-establishment bias, exploiting anti-government bias. And also these various greenwashing campaigns. So for me, this is incredible. I'm always running into clean coal, clean natural gas. Just take in British Columbia today, the effort and money, mostly your money if you're Fortis gas users, that is being put into talking about why we should use more natural gas. Guess what? In all my models, natural gas use has to go down. In all of our models. So it's really interesting, the campaigns that go on, or ethical oil. We're certainly all hearing that one. So how can we respond? The last parts of my talk. I think we do, if we don't take these characteristics into account, we'll fail. So that's the one thing I want to say, is when John Clegg gave his talk and somebody said, well, what do we do about this? People are not even listening, the science is being discredited. And his response, which I don't blame him for, was, well, I think we just need to do some more and get it out there. And yes, but I think we also have to become more sophisticated. We have to understand human cognition. We have to understand what might work and what might not work and why. And that doesn't mean we have to be stealthy or lie to people, but we need to take the real world into account in all respects and see that as a responsibility as scientists, as researchers. And that's sort of the final appeal pitch to my talk today, and I'm going to have a few slides now that show how that, I would argue, that would play itself out. And when I talk about, and part of it is to do with sort of delusions we have, right? The title to my talk, and this is where I was going to have the good and the bad delusions. I'm working on a book right now on delusions, and I'm actually focused on what I'll call the good guys, the people who want us to act on the climate risk, but what have they been trying to do? What have they been promoting in good faith, but with, I believe, not enough understanding of how humans gain information, how they think, how they respond. So, what about scientists? How should they act? Well, I'm just going to give a pitch to. I've been thinking a lot more about that. I don't know how many of you have read this book, Don't Be Such a Scientist. Okay, so Talking Substance in an Age of Style by Randy Olson. And so I almost use this as a Bible now. It's all worn out here when I'm trying to think about how to communicate. I'm going to do a radio show or whatever. And we've been able now to get him to come to He'll be giving a talk here on March 26th at 3:30, coming up from Los Angeles. He's a PhD from Harvard who was a professor of biology at Vermont, I think, and then walked away from it all to go into movie making and lives now in Hollywood or Santa Monica or something like that. So I highly recommend him. Oh, and I'm going to skip past this then. So here's the book that I just showed, and he's also made a movie called Sizzle, a global warming comedy. All right, so he's very focused on how can scientists, and so he has chapters in here in Don't Be Such a Scientist on things, so I'm just giving you the tip of the iceberg. Don't be so cerebral. Don't be so literal-minded. Don't be such a poor storyteller. Don't be so unlikable. And be the voice of science. So he's got, what did Carl Sagan do that worked? How can you learn about that? So that's on that side. And then I have to deal in my own work, or you will too, with a lot of argumentation that people can use or logical fallacies about why we can't act on this problem. So, what about the Chinese argument? So I get that all the time. Well, the Chinese are increasing their emissions like crazy, so we shouldn't do anything, or it's left hanging. All right, so the question is, if there are emissions going up around the world as people get more energy, and yet we have this huge problem that is not consistent with our attempts to prevent climate change, what should we do about it? Well, guess what? If you present this to a group of students, even high school students, you present this evidence, you get the same answer every time. So we need collective action as an international community. It's this global public good. Some countries are richer than others. The rich countries have much higher cumulative emissions. The poor countries want rich to pay all the costs, which they won't. And the rich countries can use subsidies and trade threats to get global compliance. Well, what's going to happen? Always the same answer. The rich countries are going to have to go first with cutting their emissions, but very shortly thereafter, and that's why all our modeling shows like 5 to 12 years later, they're already applying policies to and pressure on those other countries. Subsidies too, but it won't just be subsidies. And if you look at the US legislation, there was one that passed the House of Representatives, but not the Senate. John McCain's bill. I've actually looked at 9 different bills that had some good prospects in the US Senate over the last 6 or 7 years. And all of them had a requirement in there that if some country is importing goods to us and does not have similar climate policies, then they, trade threat basically. They're going to have to buy permits to sell Chinese toys in the US if they were made where the electricity generating plants were using coal. The Kyoto Agreement said, we'll do this in '97, but in 2010 we get together again, and then it's a global agreement. But rich countries will show good faith by going first, which they didn't. So those are the kind of things that I don't. So if Stephen Harper says, well, we're going to wait for the Chinese to act, or we're going to wait till we all act together, that's not how people are likely to. That's not how we're going to succeed. It's an excuse for not acting. Then another one is our emissions are small argument, right? Canada's responsible for 2% of global emissions. So this is a global threat. It's a risk. Militaristic Germany and Japan were global risks. And we are quite proud of our contribution to addressing that global risk. So there were about 1.1 million Canadians who served in the armed forces. And yet, every year at Remembrance Day, we solemnly recognize our contribution. 1.1 million, that's a lot of people. There were 35 million served in the Soviet Union armed forces, 16 million in the American armed forces, 5 in the British Empire, and it goes on and on. Poland, all the other countries in Europe who were involved, the partisans. We're actually closer to 1% of the global effort in World War II. So this is what I'm saying. You have to start thinking about how to address some of these questions. Also, there's things, environmentalists have said, we're going to stop using fossil fuels. And I think, how does that sell in Alberta? How does that sell in Saudi Arabia, even in China? And that's why I wrote about 6 years ago a book where, yes, well, I was just looking at degree of difficulty. I wouldn't give up on the idea of carbon capture and storage, and that's why I wrote that book. It doesn't mean I'm an advocate of carbon capture and storage. I'm trying to bring in the challenges that we face because of the real biases people have. People are committed to the endowments that they think they have, and don't expect that you can easily, whether or not this is a good strategic choice, I don't know, but I wanted to explain the motive behind doing work like that. Then there are other things like we don't need climate policy. Okay, so this is what I was going to call the good delusions. This is, and I'm going to just run through these. I'm on my second to last slide. Corporate social responsibility is a solution. Point I want to make is just that businesses ultimately compete on the basis of bottom line, and fossil fuels are cheap. I so often get people who want to come and do a PhD with me who've been in the energy industry, and they'll say, and these were people that I connected with, I knew them as very well-meaning. Even when I was on that national roundtable, I was with the vice president of Suncor, who's now the head of Suncor. Really nice guy, really caring about the planet. And then later on, though, when they get early retirement with a nice package and cash out their options, it's so many of them want to come back and do a master's or a PhD, and they say, I was so constrained in that boardroom because at the end of the day, it was the bottom line. So we could do stuff as long as it had a good impression, but it couldn't change the fundamental path that we were on, which was to use fossil fuels. Another one is green consumerism as solution. That's a whole large discussion in and of itself, so I can't really do it justice right now. It's very difficult when you realize just how much of what we do, even if we're sort of dematerializing as we are less interested in cars well, I mean, most people are interested in bigger houses, but assuming a lot of us are not, then we do other things that also involve the use of a lot of energy. Even all those electronic devices that we now have. Back it up through the system, and you'd be quite amazed. So I think humans are going to use a lot more energy. I think there is room for green consumerism. I think we also need to be realistic about it, though. And energy efficiency, is it cheap or not? I'm actually going to skip these. I'm not sure if I should have listed them. I'll leave them hanging there by my next book. Carbon neutrality. Maybe this last one, peak oil. And that's what I was sort of talking about earlier. The Earth's I wanted to get to the point that, so some people are saying that we're running out of oil, so the price of oil will go up. So that's, in a way, that's great news, because then we'll switch away. Well, actually, as the price of oil goes up, if you look in the year 2000 to 2008, that's when investment like crazy went into the tar sands. So actually, emissions go up as you run out of conventional oil. Same thing, oil shale. Dakota now, the United States actually has its oil imports are falling, in part because it's buying tar sands oil and oil shale from Dakota, both of which dramatically increase emissions. So peak oil won't save us. The Chinese are starting to invest in making gasoline from coal, which South Africa does already to great extent. So it won't save us. And the interesting thing, as I already told you, is that if you go after the climate threat that you have to anyway, oil prices will have to collapse, believe it or not. And they won't collapse. You're going to have a tax or some charge on there or regulations to make sure people aren't using more oil. So I have a figure here. There's way too many numbers in there. This is the entity I'm on right now, the Global Energy Assessment, and we're about to, our major report is with Cambridge University Press right now. Way too much detail here. I just wanted to say, you can see on the left, I've got conventional oil, conventional gas, unconventional gas. And if you look at the reserves, it would be so here's the production. This is in exajoules. The global system is about 450 exajoules if you added up down that column. And so oil, and like this actually equates to that earlier pie charts that I had in the diagram. Look at the reserves compared to the annual production today of both conventional and unconventional. Do the same thing with gas, and it's even bigger. And the numbers for gas keep going up. And then just look at all the coal that is out there. So as I say, peak, we have a scary amount of fossil fuels out there. And then there's the climate policy can't work argument. So now I'm on my second to last slide, so we will have some time for questions, thank goodness. I guess there's only one message I want to give, is that I have other slides in my extra slide section, a talk I used to give about Canada. Starting with Brian Mulroney in '88, we promised to reduce emissions. We set targets. We implemented policies. Emissions didn't go down when we went. And so that's why Stephen Harper can do this with some confidence that, you know, that process just keeps going on. When people were all anxious in 2008, 2009, we're going to miss the Kyoto target of 2010. I said, well, I wrote a book in 2001, explaining why we'll miss the target in 2010, because we didn't put in strong policies in '98, and I know how much inertia is in the system. Stephen Harper has a 2020 target. I already know now in 2012, he said it in 2006, 2007, I know we've missed that target. I'm writing about that as much as I can in op-eds and so on. And what did we do as policies? We basically did information and subsidies. So I'll call that a label on your fridge, a label on the car, Rick Mercer commercials, and some subsidies for energy efficient homes, insulating your homes and so on. And we have 20 years of evidence that doesn't work. That's something that I do a lot of research on. So we're going to have to, no. So does that mean that we have to have a carbon tax like BC has? That we have to have cap and trade? No. But we need some kind of compulsory policies. You need to either price emissions or you need to regulate somehow. Now in the United States, carbon tax was out of the question, even in California. Then they're sort of moving towards cap and trade to try to have price emissions. I'm not going to explain cap and trade. People can ask me if they are a little uncertain about it. Basically, regulations. If you look at California right now, it has real policies to reduce emissions. These are regulations. And they're regulations on cars, on electricity plants, on buildings, and so on. And it's similar to how we addressed other environmental problems. And if I look at British Columbia, yes, we have a carbon tax, but our most dramatic policy is one that most people don't even know about, and it's our clean electricity policy. It's a policy that Gordon Campbell implemented in January of 2007, and BC Hydro had signed contracts to build 2 coal plants for private people to build them, and BC Hydro was also planning its own natural gas pipeline to Vancouver Island and a major natural gas plant over there. And Gordon Campbell said, no new electricity generation that has greenhouse gas emissions in it. We call it a zero emission electricity policy. It was one of the first in the world. Now lots of jurisdictions have started to copy it. It's reduced emissions dramatically because we know exactly what was about to get built. Okay, last slide. What do you do? What do you do if you agree with me that it looks like our government is not telling the truth? And I mean, this is really challenging. I find it really challenging. I think about this. I discuss it with colleagues and friends because I'm a comfortable university researcher. I like to be in my office at home or here. Doing big computer models with my students, and we love what we're doing, and we interact with colleagues. Like, so what else should I be doing, though, when I see this happening? It's kind of like, what do you do if you saw this threat from Nazi Germany? Like, do you change your life at all? What do you do? So I don't know. What's your moral duty when you see that that's happening? Now, I'm learning more and more about things people are doing. I'm also learning about what has been successful. So 100 coal plants, just as in British Columbia, about 100 coal plants were about to be built in the US, and various legal actions and some demonstrations have prevented those plants from being built. Similar things have happened in Europe. What is the role of all of that? That 350.org organized the demonstrations in Washington, D.C. Last summer where people got arrested. And there's a rally March 26th. So not only is Randy Olson coming here in the afternoon, but at noon there's a rally down at the Art Gallery in Vancouver. And Bill McKibben is here, who's played a lead role in 350.org and in those Washington, D.C. Demonstrations and so on. So those are all the kinds of challenges. I'm not someone who has the sophistication to know how to organize them, but what I've told to people who are doing that is that I will do analysis for you. I will provide information that might be useful, and then, believe it or not, they've cornered me into even speaking at that rally, although I'm just going to speak like the modeler nerd that I am and just keep it real simple. I've asked people, what's the message that I should be talking about? So I'll just leave us with a quote from Václav Havel. Hope is not the conviction that action will turn out well, but the certainty that action makes sense, regardless how it turns out. Thank you very much for your attention.
Questions? Just please use the mic because we are recording this.
There was recently a TED Talk by James Hansen that's making the rounds, and he spoke there that he is now shifting to recommending a fee and dividend system as the solution. Now, that was actually the first I'd heard about that, and I was wondering in your studies of these things, how does it compare with many of the other approaches that have been proposed?
Right. So there you will hear more and more about that, and or not about that particular one, but the continued debate that goes on about what is a policy that has the best chance of success in a given jurisdiction. So the United States different than Europe and Australia and so on. So basically it would be the idea, okay, we don't think a carbon tax will work in the United States, so let's do cap and trade. Well, so you cap emissions, and then everybody is allocated certain permits from that add up to the total cap. Well, those permits have value. And so what the bill that almost passed in the US, was it the McCain bill, or even the one that did pass in the US House of Representatives, it had all this stuff worked out where we're gonna have to compensate people who are in oil-rich areas, Illinois or whatever, we're gonna have to transfer some money to them as part of this transition. So anytime you're trying to make this transition, this is that sort of getting over the hurdle that I was talking about. You're trying to make sure you build allies, so the green energy industry, promote them, get them up. You're also, in some cases, running over some people who are resisting, but you're also trying to buy some people out or compensate them. And with cap and trade, you can compensate people by giving them permits. And that's one way to do it. So if you look at those bills in the US, there was a whole bunch of bills of permits being handed out to people. Then that got discredited because people said, oh, you know, that's sort of shenanigans. We don't want to be trading. It's only going to be brokers and marketers that make a lot of money. So I know we'll auction all of those permits, get money from them, a dividend, and take the money and give it to people. And maybe we'll give more to the coal-rich regions to help them with transition and so on. Once that one, if some government starts to promote that, it will get attacked as well. It'll get attacked as being taxation in the United States. So I don't think James has got the savior solution out there. I don't say anything negative about it, publicly, but it'll be challenged as well. It's kind of a moving target. Right now, I'm doing work for the Environmental Protection Agency with a whole bunch of modelers, not under contract, but just, again, as an international group of modelers, looking at different regulations. Because that's the thing, that the failure of major bills on taxes or cap and trade has led to more of a regulatory approach. But you can design regulations so they're almost as economically as efficient as these price instruments. And don't let an economist tell you otherwise. I guess that's what I would say. Other? Tim?
Thank you, Mark. That was a great talk. And if reading between the lines, I think you were saying we should overthrow the dictatorship, but I'll talk to you about that afterwards.
I'm getting there.
I'm curious about your risk communication notions with regards to the use of fear in climate change discussions. Scientists are really they're very loath to say, oh, well, this particular catastrophic event was caused by climate change. But we do know that the intensity of storms are increasing, etc. And those events, those catastrophic events, Katrina, for example, really do have an impact on people. But we've been very shy to say that was what we should expect more of in the future.
Right. I almost don't have an answer for you. I always think in terms of probabilities, and trying to communicate probabilities to the public is very difficult. And I don't want to give up my science side of me. So I'm really looking to other people to how to do that. That's why one reason I did have that Ronald Prynne Wheel of Fortune up there, because those guys had been thinking about that a lot. And so I'm kind of looking to researchers around the world. They said, oh, Americans like Wheel of Fortune. That's the one way they actually understand probabilities. Let's put 2 wheels up there. Then they can think about spinning, and that they're going to happen somewhere along there as opposed to somewhere along this one. So those kind of things. But I mean, if someone said so-and-so got cancer, lung cancer, and is a smoker, I still tend to say, yeah, well, they would have been at higher risk. You know, I don't say smoking caused the lung cancer. I just can't. It's my training. So, you know, but if someone says there's a strong chance, this is a strong storm, we knew there'd be more strong storms, there's a good chance, you know, that's the kind of language that I would support.
Well, I guess I'm wondering about taking it one step further, which is something that was done in the anti-nuclear movement during the 80s, when the Reagan administration was saying, well, the U.S. could survive a nuclear strike if we just buried our infrastructure, and crazy things, and it got people very scared. And one of the effective methods was to go around to cities, and we did this as a physician movement, convince people in a graphic fashion what it would be like if there was a detonation over your city. What would this neighborhood look like? What would the pain and suffering be like? What would the overwhelmed hospitals be like?
Right.
Is that the sort of
Yes, absolutely. I see nothing wrong with that. And in fact, even the National Roundtable has done a new study, and I'm no longer on the National Roundtable, but they had me as an internal critic, and they've done a new study on. And you know, some economists like Bill Nordhaus tries to monetize all the time these impacts, which I'm suspicious of. You know, what was the value of the 2,000th to last polar bear? What about the 200th to last polar bear and the 20th to last? Because in economics, we say they got to have very different values. Well, how did Bill get those numbers? And you realize, as I know all the studies they looked at, it ends up 0. So rather than monetize, it is, can we characterize for people what that would look like? And I do have that. Like when I've given talks around British Columbia, I've had estimates of how temperature would change in BC, like these thermal maps, and then I've shown pine beetle infestations, and you know, and then real pictures of what that looks like. So sure.
Show Kelowna burning.
Well, actually, that would be, yeah, because you're going to have a higher incidence of those kind of fires. Absolutely. Yes?
Yeah, I enjoyed your talk. You pointed out the problems, and sort of, we kind of know what to protest against, but what do we protest for? You know, are we supposed to protest for nuclear power everywhere? Like we could,
right,
et cetera, you know.
So the global energy assessment that I'm on, I'm sort of on the policy side. You know, we have successes all over the planet in terms of climate policy, and British Columbia, I just gave you one example, that electricity policy. We have successes all over we have cases all over the planet where people have way lower emissions per capita. France makes almost all its electricity with nuclear power. Brazil is an amazing country because both their fuels for their vehicles come from biomass, and their electricity comes from hydropower, 90%, something like that. So I'm actually able to look around the planet and say, here's what the future looks like. Now, how do you actually make that happen? Well, as much as possible, we should be talking, in my case, talking about what are those commercially available technologies, what are the policies that make them happen, and by the way, what would that mean for jobs and so on and so forth. So we're doing an analysis right now, and I did an op-ed in the Vancouver Sun on that recently, where I just gave some of our preliminary results of the job creation that happened because of BC's electricity policy. It's now 5 years old. PricewaterhouseCoopers did a big study on that. And I'm now simulating what would happen if our fuels, if we started to use some mixture of electricity and biofuels in our cars in British Columbia, and we did that over a 20-year time period. And what is interesting is that increasingly now, because BC did that electricity policy, we actually have a large contingent of renewable electricity producers in BC who've put money towards an association, who put money towards research and even and media campaigns to talk about why this is part of the solution. So, and at the same time though, a lot of the big changes have happened because we've stopped stuff. Because humans are pretty good at stopping stuff, because that plays into NIMBY, not in my backyard. I mean, so that's why even with the tanker issue here, with the pipeline and the tanker, I try to say to people, I understand you're concerned about your backyard, and that's good, but please remember also that it isn't just about them moving the pipeline so that you're happy, or somehow else developing this, because those areas that you love will be devastated in any case if you allow continued development of that. So that's why I gave that example there of the U.S. coal plants. I mean. And what we did in British Columbia, that's a huge difference in where emissions were headed. But we need to go further. I think we have a few questions.
Have you seen John Cooksey's movie, How to Boil a Frog?
Pardon me?
Have you seen the movie, How to Boil a Frog?
No.
No. I will
see
send
that?
you a link. Yes, you should.
All right. Any other questions?
Everybody else should, too.
Any other question?
So maybe we have 10 minutes max for questions, just so people can get out, if that's okay. Yeah, we'll wrap it up in about 5 minutes, actually.
This is probably not a very well-informed question, but you said that one of the ways that we can tell that our government is not being consistent with their promises is the tar sands and the pipelines. And I wonder if those are really the major sources of emissions in Canada, or if there's more traditional things that are maybe just functioning on momentum now, which are actually greater proportion of the impact, but they're just not being newly developed. Do you know what I'm saying?
They're right, that they're already there, like a coal plant that's 30 years old in Saskatchewan or Alberta. Is that what you mean?
Yeah.
Yes, absolutely. So very good question. And in fact, it makes me think of, some people may have seen that my colleague who's on the IPCC with me and is Andrew Weaver, who's a climate modeler at the University of Victoria. And he came out with a paper in Nature Climate just in the llast month, showing that all the carbon, if you put all the carbon in the tar sands into the atmosphere, that would, I think if it was all the carbon, it was like 0.36 degrees Celsius. If it was the economically recoverable carbon at this point, which is always a moving target, I know as an economist, it was 0.03 or something like that of the increase. And I did an op-ed in the Globe and Mail right after that. First I talked to Andrew and said, can't we write something together, because this is getting interpreted in a funny way, but he wasn't really into that. So I did this op-ed in which I said, I presented that as a logical problem. It's everybody, and in fact, just now, the coal industry in Canada, I just got wind from a consultant I know, is doing a study showing that if we burned all the coal in Canada, it's not as much as the tar sands. So, that's right. If you took all the economically recoverable amount of coal in Canada, it's about 2/3 of the tar sands. So don't worry. That coal plant you're talking about, they'll be out there with a story on this pretty soon. The message of my talk today and this Globe and Mail op-ed I did was to say, just like some of you guys are modeling the climate system and it's very complicated with feedback effects, I'm in that community of researchers who are modeling the energy economy system. And so all of these things are happening simultaneously, and that's why I wanted to show the MIT study, and I referenced it in my op-ed, because I said what it showed is things that people don't often think about. They think about, okay, tar sands will keep operating, but we're going to reduce emissions from everything. And then it's like, well, wait a minute. If we're reducing emissions from transportation, that means that the price of oil is going to fall. And it means something that we economists call, we're going to climb back down the oil supply curve. So a supply curve is something where, as the costs are higher, you can get more of something, but that's the high cost stuff gets added on. Tar sands is up in the high cost realm. As the markets adjust to whatever kind of global or national policies we implement, then we can simulate with our models how we're most likely to get those emissions down. And what you realize is tar sands can't be part of it. Also, when we do our economics, you realize what we call sunk costs. When you put a bunch of pipelines in, you dramatically change the economics of a new investment in oil sands 25 years from now. So all of those things we try to put into our models, and a kind of parceled out, let me look at the carbon in the tar sands, let me look at the carbon in Saudi Arabia, let me look at, they can always say, this stuff is, in fact, I've got someone doing it for all the carbon, all the coal in China. still looks like the Chinese are fine. You know, like it's not their fault. So that's my response to that. Well, I had two questions, so I'll take those as the last two questions for those people that do need to leave.
So, Mark, I work in the Faculty of Education here, and so I work with teachers, among other people, around the province, and many of the issues that you're talking about in terms of how the public understands climate science, how they interpret the results of studies or what people say, comes down in the end to how people interpret science or how people think about things like probability, to take one instance of a problematic area that we don't seem to teach very well about. I wondered if you thought about what should change in the ways in which we educate young people in formal education in school settings that would prepare the way for a better public discussion of these issues, say, 10 years down the road.
Right. And so then the microphone can head up there. So first of all, take my answer with a grain of salt, right? But I had a fun experience a year ago. I was asked by the Edmonton Teachers Association to speak at their major conference. So this is, I guess, when it's a professional development day, and all the teachers were at the Edmonton Conference Center. And I was saying, oh man, I'm going right into the heart of this thing. And yet, and so they had me give a talk for the science. It wasn't just science. Anyway, it was in a session, and I had 500 people in the audience. And I have to say that I spent a lot of time preparing that talk. It's about a 45-minute talk. I can send you the slides. I really talked to a lot of educators about how to try to present this stuff. And then I think afterwards it was fun because I got feedback from people, and I would love to do it again. I think I could have done it a lot better, and then probably a lot better and a lot better as talking to people like you about what works. But just to give you a sense of some of the stuff I did, is I was really trying to think about a teacher teaching risk. And in my case, in risk, it's around us all the time. It's putting a seatbelt on. It's the one I often use is, I actually think it's a very low probability, well, my kids are older now, but when they were younger, that my house would burn down. Nonetheless, you know, there was some small probability of that, and I spent money on, it's kind of a tall house, so we had ropes that they could, these little rope ladders that they could throw out the window in a fire, and of course I had, I paid attention to the kind of materials that I bought, fire, all the things that one would do with respect to that risk. So one of the things is to talk a lot about how you respond to risk. And, but this is just my guess. Maybe some professional communicator would say, no, there's a better way to do it. So that's why I don't feel that qualified to answer it, but I've been trying.
Last question.
Yeah, well, first of all, very nice talk. As a Brazilian, I'm very happy to hear
I have a lot of good friends in Brazil.
Saying good things about the country, and I agree we have, very positive things when it comes to biofuels and hydroelectric power, but we are also one of the top emissions when it comes down to cutting forest, together with Indonesia and other countries. And also there's probably a big shift in the country now because we have a lot of offshore oil rigs, and I don't know the name in English for that new kind of oil that has been found there. It's a very deep, so there's a lot of
offshore.
I'm sorry?
Deep offshore, we call it that.
Deep offshore. There's a lot of technology being developed to collect that oil. So we have a sort of a virtual big oil base. So I'm very concerned about the future of Brazilian and other countries like the developing countries. It comes down to emissions and everything. So if your models are including, for example, the discovery of the extraction of the oil, and how does it come down to cutting down emissions from forests, from forest cuttings?
Right. Good final question then. So first of all, I was talking about some instances in Brazil which may have been done for other reasons. Like France may have built nuclear power for a technological reason, and British Columbia had hydropower endowment, as did Brazil. So I wasn't trying to say that Brazil alone is a great country, although I do think it is a great country. And I can see why you interpreted it that way. But my message was more, here, look at this. Somebody has done this. And I do know that tropical countries are very interested in what Brazil has done. Now, you know, in North America and in Europe, we cut down all the forests. And so there's a pulse of carbon that went out into the atmosphere. In tropical areas, we are cutting down forests, and there's a pulse of carbon going out into the atmosphere. And of course, I don't condone it, but some of that I almost write off. Like, I almost know that's going to happen. If you think of the areas in the northeast of Brazil, where a lot of the sugarcane is happening for fuels, these are areas that were an incredible tropical forest. 100 years ago, and they were cut down for coffee and sugarcane and so on. And so there was a pulse of carbon that went out. There's still carbon in growing sugarcane. You bring in carbon. There's carbon in the soil. So it's much better than cutting down a forest and putting a parking lot. So I think there are going to be areas of the planet that are tropical forests, and that we need all sorts of policies. There are policies to try to stop that deforestation, but some of it is going to happen. Hopefully as much as possible towards selective kinds of forestry that could still be there. And I know groups that work on that, both in Brazil, but all around the world. And so, yes, this is a problem. But it's not the bigger one, in my view, really, some of that is kind of going to happen. Try to slow it down, try to stop it, try to provide an alternative. But the carbon that was the easiest was the carbon that was under the Earth's crust, for heaven's sakes. That's what we're digging around going and getting. And that's what is, some people are going to cut down trees, and maybe they'll grow some other crop there. Maybe they'll even grow forests there one day. But to get carbon that's in the Earth's crust, that millions of years of geological processes stored down there, that's the thing that I think we really have to stop. And that's why in Brazil, I know there are people that are trying to say, don't touch this stuff, the offshore oil as well. So I'll have to end there, but I thank you very much for your attention.